Atomic components and atomic mass calculation. Here we're going to talk about the different parts of the atom, how they're different, and go over how we get that atomic masses on the periodic table. So components of the atom. Over here on the left you have all three components of the atom. You need to be able to define them, what their charge is, and what their role in the atom is. So the protons are positively charged portions of the nucleus, whereas neutrons are still part of the nucleus, but they contain no charge. If you take a look over here on the right, atom here, you have your protons mixing with your neutrons right there. That forms central dense nucleus that we were talking about with the Rutherford experiment. Now electrons are kind of the outliers. That's what kind of floats around the atom. They're negatively charged. And make sure you know these symbols. P positive, nu, N, electron. We always consider atoms to be neutral. And that means they have the same number of protons and electrons. So when we're talking about neutrality, we're talking about charge. Protons are positive charge, electrons are negative charge. They're equally positive and negative, so if we're talking about an atom being neutral, we're talking about having the same number of protons and electrons. Now you have three different definitions. You need to be able to define them and tell me the differences in each one. The first one is the atomic number. And the atomic number is simply the number of protons found in the nucleus of the atom. And the thing you need to know about the atomic number is if the atomic number changes, the identity of the atom changes. Atomic number is unique to each atom. Now the mass number, on the other hand, is the number of protons as well as the number of neutrons. So it's protons plus neutrons. So this is how much the nucleus of each atom weighs. And this number can change within the element. We can have something called isotopes, which we're going to talk about in just a little bit, or we can have the same element but a different number of neutrons. That'll make that different. Atomic mass, on the other hand, is the average masses of all the isotopes within that element. The key thing to keep you straight is it's the average masses. Those isotopes I was talking about, the mass numbers, you have a couple of different ones per atom, or a couple of main ones per atom. So you take the percentages and you average them together, and we're going to work through that in just a little bit. Now, what are isotopes and how are they different? Like I said earlier, isotopes have the same number of protons, but a different number of neutrons. So remember, if we change that atomic mass, if we change the number of protons, we're changing the identity of the element. Carbon-12, that's the name with a hyphen and the mass number. So carbon-12, if you look at your periodic table, you'll see a number 12 associated with carbon. So carbon-12, that's your normal carbon, has 6 protons and 6 neutrons. So you 6 plus 6 equals 12. An isotope of carbon-12 is carbon-13. We have the same number of protons, but now we gained a neutron, and 6 plus 7 now becomes 13. So that's the mass number. And then we can go all the way to carbon-14, which you've probably heard about with carbon dating. Still has the same number of protons. Once again, if we change the number of protons, it's no longer carbon. It's something else. But our neutrons can change. So those are different isotopes. The only thing that changes is the number of neutrons. In the next slide, we're going to talk about atomic masses. These are the three most common isotopes for carbon. So what we would do is we would take this percentage of carbon-12, this percentage of carbon-13, and this percentage of carbon-14, and we would just average them together. We're going to go ahead and do that right now. I'm going to do the first one, and I want you to be able to do the second one kind of on your own. So here's your example. When you get these percentages, you're going to convert your percentages to a decimal. You do that by dividing by 100. So what we're going to do is we're going to take the percentage and then multiply it by the mass number. And we're going to keep on doing that for however many we have. So if we're trying to find the atomic masses, we're going to put out the periodic table for chlorine. We have 75.53% chlorine. So we turn that to a decimal form. We're going to divide that by 100. So it should be a decimal. 0.7553 times the mass number, 35. That's the first one. Now you're going to add it to that much percentage. So you're going to divide that by 100. So it becomes 0.2447 times its mass number of 37. Okay, now that you have your numbers, just go ahead. You can do it all in one problem if you know how to do the order of operations in your calculator. If you don't, just do it step by step. 0.7553 times 35 equals 26.4355. Then you do 0.2447 times 37, that gives you 9.0539. So you just add those together, and you get 35.4894. Now, how many sig figs are we working with? 1, 2, 3, 4 for this one. 1, 2, 3, 4 for this one. So we need to be working with significant figures. We don't take these numbers and into consideration with significant figures. If you look back into your rules, those are called counting numbers. We never take counting numbers into effect. So give the actual calculated number in your problem as sig figs. So run this to significant figures. 1, 2, 3, 4. This is a 9. So that turns to 8. So our exact answer would be 35.49. That would be your mass. Okay, go ahead and pause it. Work to the next one. So to get full credit on this question, you'd have had to put 20 with a decimal and then label it in atomic mass units. Okay, now let's move on. Let's talk about ions. What are they? How are they different? Here's your answer. They're particles that don't have the same number of protons and electrons. If you think back to what we were talking about at the very beginning of this video, we consider all these atoms neutral because they have the same number of protons and electrons. Ions are something that has different numbers of protons and electrons. So you have two different outcomes you can have. Remember, if protons equal electrons, it's neutral, it has no charge. But let's take a look at this example. If electrons are less than protons, or protons are greater than electrons, that means electrons are given to something else, or electrons have been lost from an individual element. There is an excess of positive charge. You can do a positive sign, you can write the word positive, and it's called a cation. C-A-T. And a lot of you can remember cation because a T looks like a plus. That's how I remember cation. Cations are positive charges. Now, on the other hand, if electrons are greater than protons, which means electrons have been gained by an element, then there is excess of negative charge. So you can draw the negative sign, you can write negative out, and it's called an anion. Take a look at our example down here. We start at a neutral atom. We can lose electrons and become a positive charge cation. Or we can gain electrons, gain negative charge, and become an anion. That's how this works. You can see the number line right here. So given the definitions and the knowledge you have now, you should be able to fill this chart out. I want you to go ahead and pause this and see how much you can do on your own. Okay, remember mass number was protons plus neutrons. And charge compares the protons to the electrons. And the atomic number is the number of protons. We're given our protons, this first line, that's 5, so our atomic number is 5. Then we have protons plus neutrons, 5 plus 6, that's 11. And then we have the charge, protons minus neutrons is 5 minus 5, and that becomes 0, no charge. So how do we know what a nuclear symbol is? You take the the atomic number, 5. That matches up with a chemical called boron. So there's a symbol. Put the atomic number at the bottom and then the mass number at the top. The next one, you have a mass number. So this is protons plus neutrons equals 14. You have 8 neutrons, so you would just have to do 14 minus 8. So we'll do 14 minus 8 equals 6. You have 6 protons. So now that you have your protons, you come over here and do your atomic number. Then you can find a charge. 6 protons, 6 electrons, 6 minus 6 equals 0. So what's our nuclear symbol? Our atomic number is 6. It's going to be carbon. Carbon, atomic number 6, and the mass number goes at the bottom. This is carbon 14. Remember, that's an isotope of the normal carbon.
I must have drank me about 15 Dr. Peppers.